Okay. 4, range and standard deviation. These are two numbers that help us describe the spread of the data. They're measures of dispersion. The range is rather simple. The range is the difference between the maximum and minimum values of the set of data. So, on your morning commute, you decide to record how long you have to wait each time you get caught at a red light. And then we have the times here in seconds, 12, 58, 35, 79, and 21. What is the range? So what is the lowest? Looks like 12 is the lowest, 79 is the highest. So the range is simply the highest, 79, minus the lowest, 12, which is 67. That is the range. There is 67 units between the lowest and highest value. It's easy to compute, but it depends on only the two data values in the entire set, the highest and lowest. So it's not a very good and a good measure, and it is also very distorted. So that brings us to standard deviation. This is a measure of dispersion that can be interpreted as approximately the average distance of every data value from the mean. The distance from the mean is called a deviation in standard deviation. We have a formula for this. How to compute your standard deviation. Standard deviation is the square root of the sum of x minus x bar squared over n minus 1. X is each data value, x bar is the mean, n is the number of data values, and the capital sigma indicates that we take a sum. So we have a sum, that means sum. This means take the value, subtract the mean, and then square it. And then we take the sum of. How do we do this? To compute the standard deviation using the formula, follow the steps below. First, we're going to compute the mean for all the data values. Then we're going to subtract the mean from each data value, square those differences, add up the results in step 3, divide the result in step 4 by n minus 1, and then take the square root. So with a small data set, I recommend developing a table. We start out with our x's, and here are our x's. This is the morning commute again, our 12. They don't necessarily have to be in ascending order, so we won't bother with that. 35, 79, and 21. Now, the first thing I need to do is find the mean. So I take the sum of all my x's, 12 plus 58 plus 35 plus 79 plus 21. That gives me a sum of 205. So let's make a note here. Sum of all the x's is 205. So the mean, which is x bar, is 205 over n, which is 5, which is 41. So our mean is 41. So next step is to calculate the difference between x and our mean. So here I have 12 minus 41, which is negative 29. Here I have 58 minus 41, which is 17. And I have 35 minus 41, which is negative 6. Then I have 79 minus 41, which is 38. And then I have 21 minus 41, which is negative 20. We want to square those differences, so we're taking x minus x bar and squaring it. So negative 29 squared is 841. 17 squared, 289. 6 squared is 36. 38 squared is 1,444. And 20 squared, negative 20 squared is 400. So then we add all these up. 841 plus 289 plus 36 plus 400. And we get a total of 3,010. So we're on step 4 here. Now we divide this result by n minus 1, n being 5. I want to make a note of that. So n minus 1 equals 4. So we take our 3,010, divide it by 4, and we come up with 752.5. And our standard deviation is going to be the square root of that, which is, to 2 decimal places, 27.43. That is the process. Now, you don't have to use a table, but it's easier to use a table to keep track. Keep everything in line, make sure everything done. And that is it for station.